Well, well, what has the cat dragged in today? It's a video tutorial on Plinko. Continuing on with this series, this video we're going to take a look at getting some functionality into our ball. We're going to get it moving side to side and releasing it. Now, before we get into the actual coding, there is one small change that we need to make to the ball. And that is we need to turn, well, we don't need to turn off gravity per se. What we need to do is stop it from automatically falling as soon as the play button is hit. So what we're going to do is we're going to select the ball and we are going to turn on is kinematic. Turning on the kinematic property or setting the kinematic property to true on a rigid body tells the physics system that, hey, I want you to calculate collisions, but I don't want you to actually have this object influenced by the physics simulation. Other simulated objects can hit it, can bounce off of it, it can plow through other simulated objects, but it itself cannot be affected by the simulation. It's also a really great and convenient way of disabling gravity as well. So by setting this to be kinematic, I am telling the system I will completely 100% control this game object. And so now with that kinematic property on, when I hit the play button, the ball does not move. And that is what we want going into the code. All right, so I'm going to go into my scripts folder here. And I'm going to create a new C# script. So right-click, create C# script, and I'm going to call this ball control. I am then going to open it up in Visual Studio, which happens to be on my other monitor. So let me get that yoinked back over here. And then before I actually get into handling the code, I'm going to make sure that I have this actually attached to my ball. So coming over here and looking at my components, I'm actually going to collapse down my mesh renderer. I don't really need the mesh renderer expanded. So, yep, there we go. Drag that component over there. And I've got my ball control script added in. So the first thing that we are going to do is get it moving side to side. So the first variable that I'm going to put in here, starting off on line 7, is I'm going to put in a public, because I want to be able to modify this in the inspector. Float, because it's going to be used in floating point calculations. And move speed, which I will set to a default value of 5. This is going to control how fast we can move back and forth. Once again, I really don't need a start method. So I'm going to go ahead and get rid of that. Delete out a few extra spaces. And then I can start writing my update. Now this is actually, before I start writing the update, we have to think a little bit here about state. Game objects have state. And I'm referring to game objects here in the general sense, not the Unity-specific game object, but just in the general sense, objects in a game, or game objects, have states. Now, it's moving, or it's not moving, or you can fire, or you can't fire. The door is locked, the door is closed, the door is unlocked. The door is in the process of closing. Game objects have states. And so I need to think a moment, what states is this ball going to have? And it's really going to have 2 states of existence. It's going to have its static state, where it's not falling. I can still move it, but it's not falling. And then it's going to have its falling state, where it's under control of gravity, but I can't move it. And so what I am going to do, since it's a very binary, it's this state or that state, I'm going to switch back to Visual Studio, and I'm going to put in a bool, not public this time because I don't need to access it in the inspector. I'm going to say bool can move, and I'm going to set the default to be true. Because when the game starts, I want to be in the moving state. I can move the ball. It's only after that I release it that I want to set this to false. So the first question I need to ask and update is, am I allowed to move? I'm asking a question, so that's an if statement. The variable that I'm using is can move. Now, you don't have to put in this next little bit. Oops. Although it would help to actually spell the word true correctly. Go ahead and put in my curly braces there as well. So you don't have to write it this way. It is completely 100% syntactically correct. And in fact, in a lot of code, you will see it written this way, if can move. I don't like writing the code like this because it's not explicitly clear what you are asking. What value do I expect this to be? Do I expect this to be true, or do I expect this to be false? It's not explicitly clear. By putting in the double equal sign, because anytime that you're checking for equality, you need to use a double equal instead of a single equal. And by putting in the double equal sign and saying explicitly if can move is equal to true, I am making sure that whoever is reading this code, including myself, knows what I am checking here. Because I promise you, 2 months after you write a piece of code, if you go back and look at it, it will be like somebody else wrote it. You'll be looking at all of these words and you'll be Gandalf. I have no memory of this place. I promise you, it's going to happen. Make your code as explicit as possible. Actually, probably should be putting in a lot of comments here too, but I'm just cutting out the commenting part to keep the videos flowing. Okay, great. So I can move. What is the next step? I need to calculate an offset. Just like we did with the space game, only this time I'm only calculating the offset in the x. So I am going to say vector3 move offset is going to be equal to, well, initially I'm going to set it to vector3.0. It's always a good idea just to initialize variables to a known state. So move offset is equal to vector3 0. Next, I am going to say the x property is going to be equal to input.getAxes. Remember that command from last time? Based off of the input system. And we are looking for horizontal. Again, as a reminder, where we find this definition is if we go back over to Unity and we look at project settings and we go into input manager. These are all of the axes that we have access to. And horizontal is bound to left, right arrow keys and the A and D key. So that is where the horizontal keyword is coming from. Now, we could also continue this line out, but I'm going to break it out into 2 lines. We could do these 16 and 17 could be all on one line. I'm going to say move offset.x equals move offset.x times move speed times time.delta time. Because getAxes horizontal is going to give me a range of -1 to 1, depending on whether AD or no keys are being held down. I have to scale that directional vector by however fast it is that I am moving. And then I have to scale that by time.delta time so that the speed value is representing units per second, rather units per frame. We never want to code things in terms of units per frame. We want to do things in terms of per second to make our logic frame independent. Most of the time. There's exceptions to everything. All right, so now that I have my offset calculated, I can add my offset to transform, right? Well, yes and no. So here's what's going to happen. So I am going to say, just like we did with the space game, I'm going to say transform.position, lowercase t transform holds all the information in terms of movement, rotation, scale. And I'm going to say plus equals, which is the same as saying transform.position equals transform.position plus move offset. Let's test the code. And as always, as a reminder, if you need to pause the video here for a moment to make sure that you have everything typed in correctly, go ahead and do so. Make sure you have everything typed in. There's no red squiggles of doom. Make sure you save your codes, that you do not have an asterisk here. And once all of that is done, switch over to Unity. And let's test this. So I'm going to hit the run button. I expect no movement if I'm not touching any keys. That's what I get. I expect the ball to move to the left and right when I use the A and D keys. And I expect the ball to stop. Ball? Why are you going through the walls? Is it just that one, or is it both walls? Oh no. It's a ghost ball, apparently. Right, no, that's very much not what I want. Okay, what's going on? The key thing to remember when doing anything with computers, especially programming, computers are really freaking dumb. They will do precisely what you have told them to do, and no more and no less. We have told our ball to move along the x-axis. Nowhere in here are we saying anything about stopping if you hit a thing, or if you exceed a certain value, which we most definitely want to have that in our code. So how are we going to fix this? Well, there's lots of different ways. Since we're using a kinematic, and I don't want to get too crazy with the code, let's just take a look at what x values do we want to stop at. So I'm going to select the ball. I'm going to zoom in here. I'm going to move it all the way over. I don't want the ball embedded at all. So I'm just going to move it over. And what is this value? So it's like, just to keep things neat, not that it's really required. If I put my ball at negative 12.25, that's pretty close to the wall, and it looks like I'm just about touching. And of course, it would be the same if I took the negative off. Moves it over to the other side. This is the importance of keeping our level nice and symmetrical when we built it, because we can do things like this. So it looks like my limit is 12.25. Now, if I have to adjust the level, I'm going to have to adjust this limit value. So what I'm going to do is I'm going to make this a class level variable that I can edit in the inspector. So I'm going to go back over to Visual Studio. And this is a common thing that will happen. You will come up with your initial logic. You will implement it. You'll go, oh, I forgot about X, or I didn't think about checking Y. And you'll have to go back in and add some variables to be able to handle that exception. So can move. I'm going to hit enter. I want this to be a public value. And I am going to set this as a float. And I am going to say lowercase l limit left. and set that equal to negative 12.25. Remember, whenever you're typing in floating points in C#, you have to end it with an F for floating point. Otherwise, you will get red squiggles of doom because of some casting issues, the exact nature of which is not important right now. So remember to put that F at the end. We want single precision, not double precision, because double precisions just waste too much memory. I'm also going to put in a public float limit right at 12.25 F. Again, the reason we're making these public is so that we can edit them later on. Coming back down to my update method, I'm going to have to alter it slightly. So after I calculate this move offset, I'm not going to just automatically add the offset to my position. Instead, what I'm going to do is I'm going to declare a new variable. Whenever you have a new piece of information to track, do not hesitate to declare a new variable to track it. I now need a temporary variable to hold what my new desired position is. So I'm going to say vector3 new position, and I'm going to set this to be equal to transform.position plus my move offset. Now I can check the x value of this new position. By the way, the reason why we must use a variable here, you might be getting a little bit clever and thinking, oh, well, hey, wait a minute. Why don't I just add the move offset to transform.position, do the way it was, transform.position plus equals move offset, and then ask the question if transform.position.x is greater than limit left. Well, the issue with that is you will get an error when you attempt to do this. C# is not going to, or Unity, I should say, is not going to like this due to how the access limitations are on this property value here. So that's why we're not doing it that way. I'm going to ask the question if new position.x is greater than, just a single greater than sign, limit, not limit left, limit right. What do I need to do? And this is an excellent typo fixing type. So I'm getting red squiggles of doom here. Why? I've got limit right and limit right, right? If I mouse over the red squiggles, it tells me the name limit right does not exist in the current context. What happened is I goofed up here and I put in a capital I instead of a lowercase I. So a capital I and a lowercase I are different characters, therefore these are two different variable names. Easily fixed. And again, the reason why I do live videos like this, so you can see the types of typos that you might make while doing this yourself. All right, simple enough. If my position is greater than what my limit is, I will say new position.x is equal to my limit. And I will also ask the question if new position, oops, there we go, dot x is less than limit left, new position dot x is equal to limit left. There are more condensed ways that you can write this. There are more complicated ways you can write this. This is just a way that I feel is the clearest to read. Double check, make sure you've got everything typed in correctly. Pause if necessary. Save, so we get rid of the asterisk. Hop over to Unity. Let it recompile. I'm going to move my ball back over. Set my X to 0 here. Move it back over to the center. Hit the play button to test. And right. Forgot a step. So I'm not moving. I was moving before. I'm not moving now. What happened? Well, in the process of refactoring, we forgot to do a step, which is also why I always test little micro changes. I want to know, did that change I just made work? And what we forgot to do is after fixing or potentially fixing our new position, we have to write this new position back into the transform. So transform dot position equals new position. Save it. Hop back over to Unity. Test it. No movement with keys, expected. I can move left and right, expected. I can no longer move past the left edge. And I can no longer move past the right edge. Hop back over here. And here is the code one last time. Pretty easy. And again, the hard part about coding isn't the actual logic involved. It's knowing what the right words are. It's like learning a foreign language. You got to know the right words. You got to know the right grammar. Once you got that figured out, being able to say things becomes a lot easier. All right, one last little bit of functionality on the ball before we will end this video, and that is releasing it. Now again, this is all going to be going inside my if can move block here. Because I don't want to be able to release the ball when it's already been released. So now I need to ask the question of, well, which button do I want to use actually to release this? I'm going to use Fire 1. You could use any of them. You could use Jump, which is the space bar. Fire 1 is the control key. I think Fire 2 is Alt. There's lots of options here. I'm going to use Fire 1. So I'm going to say if, anytime we're dealing with keys or buttons or anything like that, it's under the input class. So if input dot get button Fire 1. When you're checking buttons, you have get button and you have get button down, which is actually what I want to use. The difference here is just like same's true for keys. Get button down returns true for the very first frame that the button was pressed, whereas get button fires every single frame. So I'm going to say if get button down, Fire 1. There's a couple of things that I need to do here. One, so I have to manipulate the rigid body to turn off kinematics. And then the other is I need to make sure that I set the can move flag to false. So I'm going to do that first. If I have released the ball, I need to immediately set can move equal to false. I no longer have direct control over the ball. The other thing that I need to do is I need to turn kinematics back on. Now, how do I know how to do that? Hop back over to Unity and look at the ball. What property am I trying to manipulate? I am trying to manipulate is kinematic. What component does this belong to? It belongs to rigid body. So therefore what I need to do is I need to get a reference to the rigid body component, and I need to manipulate the isKinematic property. The way Unity works, with very rare exceptions, what the name that you see here for the component and the name that you see here for the property are the exact same names that you will use in code. So what I will do is I will say get component with the angle brackets. That's important. And inside the angle brackets, I'm going to put in the component type, which in this case is a rigid body. And then since this is a method, I still need the closing parentheses. So what will happen is if this component exists on the game object, it will return a reference to that component. It will return null if that component doesn't exist, but that is a discussion for other videos. So I'm going to get the rigid body component. Now I need to manipulate its property. Anytime I need to manipulate a property in C#, I use the dot operator. And then the name of the property, although you can already see it in the pop-up list here, was isKinematic, and there it is. And I will set isKinematic to false. Save it. Hop back over to Unity. Hit the run button. And if I click or hit control, the ball drops. Now we do have a bit of a problem. And that, well, one, it drops perfectly straight. So it becomes a lot easier to just perfectly line it up and drop it down, making this almost not a challenge at all. You know, the perspective maybe gives you a little bit of a challenge, but that's it. The other issue is that if you are precise enough about it, you can drop it so that it perfectly falls and lands on a peg here. That's not what we want. That's not what we want. So there's a couple of other things that we are going to do. One is we are going to add some force to this, which again requires us to get the rigid body component. Now, I'm not going to do this for this particular code example. But it probably would be more efficient, instead of using get component 3 times like I'm going to be doing here, to use get component once, save the reference, and then use the reference from that point on forwards. But I'm just going to go ahead and stick with the simpler getting the component version every time. Partially also because I want you to get practice typing in get component, because it's a really important thing. So I need to get the rigid body component again. So I'm going to get component rigid body dot. There we go. And what I want to do is I want to add force. Now, there's 4 different versions of add force. That's not at all what I meant to do. There's 4 different versions here. As the box jumps around on me. Thank you, box. Version 4 is the one that we are going to use. pass in the XYZ coordinates separately, and then the force mode. That force mode is actually really important because if you don't specify that this is an impulse, like a single burst of energy, then the physics system gets a little weird about it, for lack of a better word. So what I'm going to do, I'm only going to add force to the X coordinate to sort of represent the player not being able to perfectly release the ball every time. And this is going to be random. So what I will do for the X property is I'm going to type in random, capital R random, dot. Apparently this is just not my day for typing. And I'm going to want range. Don't use random range. Do not use random.random range. That is deprecated. Don't worry about what that means. It just means you're not supposed to use it. Use range. And the range I am going to give it is minus 5F to 5F. The F is really freaking important because if you don't put the F in, it's going to be integer values, meaning it'll be 5, 4, 3, 2, 1, or 0, which is really not what we want. We do not want this to be 0, ever, for any reason. We always want to have some sort of offset to this. So the F's are important here. Then for the Y and Z values, those are both zeros, so comma 0, comma 0. And then we need the force mode, so capital F. It will detect what this is supposed to be, so I can just hit tab here, dot, and I want impulse. I'll use the arrow keys to select it. Close it off, semicolon, there we go. Now, we could also add a little bit of a random rotation on there, but honestly, this is probably good right here. Save it. Make sure you got everything typed in correctly. Switch over to Unity. And now, when we release it, it's going to have a random path. Although it does seem at the moment to be really favoring the right-hand side. But, I mean, that's random odds for you. There we go. There was one that almost went completely straight down. Randomness is, well, random. You can never really tell if it's working right or not. It is working correct. Sometimes you will get it. It's like, I just did 5 in a row of going to the right. It's like, yeah, well, you also have a chance of doing 10 to the row to the left. Now, if it seems too extreme, you can modify those values. But, of course, we did what's called magic numbers here, which is generally not a good idea. I'm not going to go through and change this. I'm just going to point out if you want to make the effect less drastic, you can change these numbers here. But this minus 5 and 5 is what are called magic numbers when it comes to programming. What do they do? How do they work? Who knows? It's magic. I mean, legitimately, what does this represent? 5, what? Is this the average force? Is this an unupgraded value? Is this an upgraded value? What is this value? Why is it minus 5 and 5? And it would get even worse if we had other 5s in here. It's like, are those other 5s related to these 5s? I don't know. Variables, even if they're not going to be, exposed to other things to be edited, generally speaking, if the number has some kind of meaning beyond being literally a number, should probably put it into a variable. I'm not going to do that here. I just wanted to point it out that, yeah, this is a prime candidate for using a variable. Not only that, using a public class level variable so we could edit it in the inspector instead of having to come into the code to control how much force is applied left and right. All right, this is one heck of a long video, but hey, we got our ball's functionality just about finished. The functionality we're going to take a look at in the next video is going to be the functionality with regards to our goals and running into that containment bar down at the bottom of the screen. So we're not quite done with this code file yet, but that's more than enough for one video. If you found this video helpful and useful, or you just in general liked it, a thumbs up would be appreciated. If not, the thumbs down button is right next to it. Until the next video.